Welcome to the last session of today. We've made this joke that Switzerland is such a rich country that they can afford having 4 closing keynotes, not just one. So sailing mode Java, which means we're going to go on the surface, where occasionally, sometimes maybe a bit deeper, but not very, very deep because time constraints. Yes. So hello, ich bin Piotr ohne Vokale. Yes, in Polish that's Piotr Przybyl. You can find me on social media if you're really interested. I bring bread to my table by working as a software solutions engineer. Sorry, I used to be software engineer, now a solutions engineer, and trainer sometimes for a startup called Atomic Jar. And I also sometimes write, stuff for my blog post, blog page, softwaregarden.dev. Yes, so I've been doing Java for quite a while. Even when I'm on holiday, Java is somewhere in background. I started working with Java 1.3, then I had to backport some code to Java 1.2, meaning I've seen some migrations and quite a few Java versions. We've decided, just with the voting who you are, so we know who we are, and just a shameless plug, who you can be, so you can join us at Atomic Jar. We are not of these startups who keep money in Silicon Valley Bank anymore, so we have money to pay for the salaries. So DM Sydney Miller if you're interested. And another shameless plug, today I'll be using the product I've been working today, before as a software engineer. So if you're eager to try it on, there's a free trial. You're welcome to try it. And caveat auditores, today we're going to experiment quite a lot, right? Because Java 20 hasn't been released yet, and I'm going to use IntelliJ EAP, so things may explode. So let me apply this health and safety protocol, make sure that the experiment is working quite okay. Yeah, caveat auditores, let the audience beware, because I am just a human being. I can make mistakes, right? So it's now on you. Very nice. All right, so Java 19. Today I'll be covering the latest official Java version and the one that's about to be released next week, if I'm not mistaken. So Java 19 came to life last September, right? It had, some could say it was like a moderate in size release because only 7 JEPs. So we had more JEPs, right? So 7 is not a huge number, but important is what's inside these JEPs, right? So release notes, if you're eager to click on this and read the whole thing through. If you're not that much into reading, you're in the right room, right? And Java 20 is going to be released half a year later, which happens next week, right? Beginning of spring. Very nice. Also 7 JEPs in total, but I would say even a bigger release. No release notes as of yet because it's officially at least not yet GA. So here we are, the 7 JEPs that were released half a year ago, and the 7 JEPs that will be officially released soon. And interesting thing about this, if you take a look about this, is it's incubator, preview, 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 incubator, incubator, right? So a lot of things are still in this, let's say, trial mode. It may change quite soon. All right, so that would be it. We've covered all the JEPs. Thank you very much. Time to enjoy your coffee and grab some t-shirts. Unless you'd like to stay with me for another 40 minutes. Okay, so there is this question. Shall I abandon the latest LTS and migrate to Java 20? And what's your answer? No? Who said no? Okay, and who says yes? My answer would be yes, of course. Your mindset should be set to using the latest Java version that's out there, even if it's not LTS, unless you have really good reasons not to do that. But I mean really, really good reasons, right? And there's a number of reasons why you should switch to the latest Java. For example, performance improvement and whatnot, and also possibility to change the latest stuff and so on and so on. So I dare you to start using the latest version to update your Docker files, should you still have any, and start using from in 2 weeks from now on the latest, right? And because the non-LTS doesn't mean it's banana soft. on Monkeysoft, right? It's well tested. It got enough care, it got enough love and whatnot. So LTS is more or less like, or shall I say, LTS isn't strictly speaking technical term. It's more like about licensing, that you call someone will pick up the phone and answer yellow, and when you like want to complain about something not working and whatnot, right? Yes. So there's been change in the LTS cadence, so it means that now we should see LTS versions at least from Oracle every 4 releases, which means that the one we're going to see next September, or this September, depends how you count, September 2023 should be LTS, right? If nothing changes, of course. So in short, what happens throughout these 2 Java versions? There are no new language syntax changes. I mean, no new keywords or contextual keywords or whatever, right? As a standard feature. But we have, for example, this when, right? With pattern matching. There was like, if you were able to attend a previous talk given by Mario Fusco, there's like going to be like huge change to concurrency, right? Or addition, shall I say. There's going to be a change to the way we process data. This was nicely presented by Edson Yanaga, for example, earlier today, that with this, pattern matching and whatnot, we can get rid of these visitors patterns and so on. And there's also like huge change or huge improvement or new way how we can call the native stuff, right? Yes, so this is it. So a lot of them, if not all of them, are preview features. How to enable them if you just go and fetch or clone the project from GitHub, most probably it's not going to work. So first you need to make sure you have the proper Java version installed, and then that you're using it with this enable preview flag, right? So make sure that you toss -- enable -preview wherever it's needed, right, in your POMs, Gradle builds and whatnot. If you're really intrigued how it's working under the hood, like you can play the piece of this video. Yes, so concurrency, very nice. If you have missed the previous talk, it's just sometimes platform and OS threads can be basically too slow to create or too costly to create, right? And sometimes we have to go beyond. And some say this is the reason why reactive started to be a thing, right? And there's also like a limit to the number, right? So initially, back in the day, we were super happy and excited because we could finally stop using processes as this, carriers for new things. We could switch to threads. So we had this very nice thread per request approach. But then we hit the limit again, so we cannot use thread per request anymore. And yeah, many of us have tried reactive. Turns out it's not that easy to debug and troubleshoot, right? Who's been trying to glue some stack traces from reactive calls? Yeah, who enjoyed that? Keep your hands up. Okay, what's wrong with you people? Yeah, and another thing is that we are lacking sort of async await, which we can know, for example, from JavaScript world, right? That we don't have this concurrency structure or idiom or whatever. Right, so there is this new addition coming to Java, right, from Project Loom, and some people are asking ourselves or starting this yet another holy war, if this is the biggest change since Lambda, right, was introduced to Java 8. And there are basically 2 camps. One say, yeah, this is like almost as big, and the others say, no, this is even bigger, right? My job is not to take part in this holy war. I would just love to show you, to tell you quickly what's the thing, what's the change, right? And so currently in concurrency we have these 3 JEPs, right, in operation: virtual thread, structured concurrency, and scope values. And the cornerstone of this is virtual threads. So this new kind of threads, they used to be called fibers, and there were also like perhaps other names used. So right now they called virtual threads. And the idea is to not reinvent the wheel, because over 2.5 decades, Java developers and Java ecosystem got used to threads. to a concurrency model when we use threads, right? So the idea is not to use something new, something that doesn't fit, but to use basically something that is still a thread for example, from consumers' perspective, right? And they work more or less like this. If you have a city, right? Especially in Europe, as we know, this might be a problem. We can't widen the streets however we please, right? And if there's more cars coming, right? So this means traffic jams and whatnot. So the idea that we have is let's use taxis, let's use car sharing, right? So when, for example, when you drive somewhere, you don't have to park your car next to the bar because you're having good time with your friends inside the bar. So then you have to take this car to drive back home, hopefully intoxicated, right? Sorry, not intoxicated. Yes, and the whole idea behind this is let's use some car sharing. Right, so instead of this car, this resource to be waiting for me when I'm done doing something that cannot be done, using this machine, then I can simply call for taxi or I can call Uber and it will take me back home or like to the next destination, wherever I have to go. And as Mario said, this taxi corporation is called right now Fork and Join Pool, right? And the idea is that these virtual threads are meant to be cheaper to start, much faster to start with less overhead, and that they will unmount the carrier thread where they are waiting or spending time like in waiting operation, especially for I/O, meaning waiting for like data to be read from your storage or waiting for that network call to come back and so on. And they are always daemons, right? Woo, demons, and always with a normal priority. So this cannot be changed. Let me show you. The idea for this talk is that I will try to use it with some code, so that we can make sure that I'm not lying, right? Yes, let's try this to run this test and see if it works. It does, very nice. All the tests are passing. So this is one of the ways how you can start a virtual thread which is unstarted. And as you can see, when you try to call stop, suspend, or resume, it will call a supported operation exception. And if you try to make it non-daemon, it will also throw an exception right into your face, right? You may want to make it a daemon again, but it's like, it's no OP, basically. And even if you try to set the priority to something else, it will be always normal priority. And there are also like other tests that, at least in Java 19 and 20, you could opt out from having thread locals, but turns out this is not going to be a thing in Java 21, at least as was the state of yesterday. Right, and there is no magic switch like -XX or -D or whatever, that suddenly your code will start using virtual threads, right? You have to go to your source code and exchange every place when the new threads are created to tell basically your program by using JDK that from now on I want in this place to have virtual threads. So you may go for of virtual and then start, right? And if you're happy to exchange one dot for one extra character, you can go like this, start virtual thread. This will also work. And of course, you can have like executors. Please notice this thread per task. Very nice. It's a hint. And you can also create a factory of virtual threads if you really need to, right? So this is how it works. And the question is, what is this fuss all about? So I happen to have a small demo like this executors demo, and on my machine, like what it does, it doesn't do anything productive. So don't do that at home. What does it do? I'm trying to give us an impression how much it will take. For example, if you want to create 30,000 threads, let's say every thread will wait for just 5 seconds. But maybe let's not do that on production, just to mimic this request or thread per request. Who says it will work? Who says it won't work? It depends on the settings of your CPU. At least for my machine. I could like run my system in a different way, but the way it is configured right now, it should work. Let's see if it works, because I might be telling things. So yeah, basically every 5,000 threads, we're just going to print a number to give us like more or less what's the current millage, right? So yeah, we have like yeah, like 30,000, right? Let's see if I can go for 50,000 threads. All right, 50, yes, 50. And let's see if that works. Come on, move on. Oh, unfortunately it doesn't. What happened? What's the error? Any ideas? Come on, people. Sorry? Yes, you're right. I brought them from Poland. I throw, you catch, okay? So this is not exception handling, it's jolly handling, okay? Good. Almost, very nice, very nice. Yes, not enough resources. That was true. Basically, we don't happen to have enough memory, if I'm mistaken. Let's scroll up, this is so tedious, right? Yes, memory, yeah, memory. Not enough resources. That's the point. So I could tune the thing with the switches and maybe fit 50,000 threads. But then the story will happen for like more threads or more requests hitting us in a peak, right? Especially if we have to wait for some other operations, right? So what I can try doing is have a different executor, and now I'm gonna run this new virtual thread per task executor, right? And let's see if it runs now. Let's give it a spin. Let's give it a spin. Come on. Yes, it worked with 50,000. Let's try 500,000. Come on. Boom. I guess printing out to standard output is slowing us down. And of course, I'm cheating a bit because I'm not calling like join or anything. So I'm just interested in creating those threads. But as you can see, we could go with this number. And maybe we could even reach millions, right? With all the caveats that you should remember and from Mario's talk. And if you haven't been here, you should watch it, because it's like, you know, there are hidden, like there's a price for you to pay for this, right? Which brings me to this other slide. And if there's just, because it's getting late and your brain has capacity to only remember one thing from this very talk, I would love you to remember this thing. That virtual threads won't magically squeeze more juice out of your silicon, right? You need to remember what's the thing that you're running. If you're waiting a lot and you're wasting time and your threads for waiting on things, yeah, then probably switching to virtual threads will help you. But if you're just doing pure computations and your algorithm won't benefit from virtual threads, then you will see like you know, that there is no more juice, right? So please remember this. Just don't go for, yeah, virtual threads will make you faster. Not necessarily. Yeah, and there are things you shouldn't do with virtual threads. And here the list goes. You shouldn't reuse them. I mean, you can, but the idea is they are so cheap to create that you should just create a new thread, a new virtual thread, whenever you need one. That's why we had this new thread per task executor, right? So we're just creating new ones. We shouldn't, because there were ways people were trying to deal with back pressure, right? So not to have too many requests, just to refuse more traffic coming in and so on. So we were used to pull threads. And this is something you shouldn't be doing with virtual threads. They shouldn't be used for pulling. For this, you should be using any other synchronization mechanism, right? And there's another thing, we shouldn't pin virtual threads. And what does it mean? It means that when we try to go to this restaurant, have a good time with our friends, we tell the taxi driver, keep the engine running. And there are two restaurants called like this, when we tell the driver, keep the engine running. One is called synchronized block or synchronized method, and eventually we might get rid of this limitation. And the other is native call, right? And how to detect these? Let's say, after seeing Loom and virtual threads performing so nicely, you might decide, yeah, tomorrow I'm switching my application, our system to virtual threads. I mean, to hell with that, YOLO and so on, right? And then it might happen that you are pinning your virtual threads. And how to detect that? So you may either go for this JDK trace pinned threads switch, especially full, because it will give you like a full stack trace where you're basically making your virtual threads pinned, or you can listen to Java flight recorder events. Anna Maria was showing you how to do that like few sessions ago, right? And how can we do that? For example, I have this dummy example, which is a Greeter microservice, right? And it's using HTTP server, which came with Java 11. What it does, it's just calling basically something out there in the internet if and to obtain this file as a greeter. So it will, like, I don't know, print the number of bytes or something like this, just to make this network round trip, right? There and back again. And then the question is, how do we test it, right? And if you mock this, or if you run this server locally, or even in your I don't know, like in your infrastructure, chances are the response might be quick enough so you don't detect that the thing will get blocked, therefore pinned, right? So what you might need, just instead of having this single call in your test, is to use toxiproxy. And then we can say in toxiproxy, let's make this round trip last half a second plus minus 50 milliseconds as a jitter, right? And then we will see if any caller of this HTTP client will make this thing blocked and therefore pinned, right? And therefore that will like downgrade the experience we should be having using virtual threads, right? And for this, we're going to use test containers, of course. So instead of spinning all these things and installing, or some people say infecting our machines with like Nginx and toxiproxy, we're gonna run them in test containers, right? So I should have an example for this. Yes, so this is it. I have this simple program, right? So this is my program. I'm just creating an artifact, not a JLink image, because let's say I ship this artifact, so people run this on premises, on their own stuff, right? Like good old way. And what I'm creating 3 containers, as you have seen. So Nginx, and between Nginx and my Java stuff, I'm going to use toxiproxy, and then I'm going to say that the latency for this thing should be half a second, more or less, right? And I'm copying this thing to my Java container using Java 20, right? And then I'm just going to like obtaining the URI, so the traffic goes through this toxiproxy, right? Through this intoxicated route, so to say. And then basically I'm going to see if the response code is okay, meaning the greeter performed 20 like round trips, for example, and that there was no unpinned in my thing. So let me run this test. Maybe this time it will pass. We'll see. So see, this is how I'm trying to emulate for my laptop or for CI or for every environment for this test, the whole network, how it's running, right? To see like how virtual threads in this case will they help me or will they help me not? Will the test pass, or who's running tests every day? If you don't keep your hand up, like do something to be able to answer positively next time, right? Yeah, so the test was green, so it turns out that at least in this very call, we're not pinning any virtual thread. But let's go here, let's go wild, and let's see, this is this HTTP client, and let's call it from a synchronized block, right, this time. So maybe here we will pin now our virtual thread, because the whole thing is supposed to be running in a virtual thread. See, I'm starting virtual thread like a good low-level way and whatnot. And now let's try to run this thing, with Maven wrapper package, and let's see what happens, if the test will pass or not. This time I will run this like this CI way, so to say. Come on, come on. Oopsies, daisies. And I didn't call. Oh, I guess it wasn't. Yeah, sorry. It didn't have like incubator module. Let me try here. Let's run from this thing. Maybe I didn't set up Maven properly. Sorry, not this demo. Come on, behave, Piotr. Where is it? Where is it? This thing. Sorry, apparently it's getting late for me as well. La la la. And it works. Come on. Oh, maybe because we didn't clean. Let's see. Let's see if that was the case. Maybe even clean or something. I was expecting it to fail, and it works. Like, not good. Alrighty. And let's try here. See, experiment. That's why I'm wearing this stuff, because it should be working. Yes, the test didn't pass. It didn't pass. But gosh, because it doesn't have the flag. Class. Oh, see, I created such a good test that now I can't make it work, which is surprising because anyway, if we run this thing and it tells us that the thing is pinned, this test won't pass. Right now it's failing because of another reason, apparently. Yes, because it doesn't have this switch, and maybe I shall try it later. But this was it. So then you can basically, this way you can ensure that the thing is that you're not pinning your virtual threads. Or if you're interested, you can also test it using this JFR unit from Gunnar Morling as well. Then you can listen for Java flight recorder events, right? If virtual thread got pinned as well. But then it's not like testing your whole artifact. Okay, and I described the thing, and it was working back then on my blog. Should you be interested in that? Okay, the next thing is structured concurrency. And it's about having better idioms for multi-threaded code, and it should help us eliminating thread leaks and the thing called the issues called by cancellation delays. And it's still not about replacing interruption with cancellation in Java, right? At least not yet. We'll see in the future. And this is how it works. So we have this structured task scope, right? And maybe I can show you in code actually. Let's try another test. This test, right? What it does is I have this shutdown failure, right? And I'm trying to run this service and this service, and whenever one of them fails, I expect this whole thing to fail like within 20 milliseconds on my machine, meaning that the cancellation actually took place and kicked in. And how I'm telling, just for purpose of this test, I'm gonna like fast forward to the next thing. I'm going to use this scoped values, right? Which are like new and better and immutable and one-way street for like thread locals equivalent. So I'm gonna say that the fail B for true in this scope, and I'm running this structured concurrency, and then I have to join to wait for the results, and then I'm getting the results. And of course, this thing should fail. That's why I don't expect this to happen. We shall see how this experiment works. And then if it really fails, it should happen within 20 milliseconds, right? And this is what we get from this approach, from structured task scope shutdown on failure. And this looks quite similar when you take a look to what we have with executioners, right? Execution service. Sorry, not executioners. CDU. So instead of submitting something with scope, I'm basically forking it, right? And then, as you can see, even if I tell the B thing to fail, then the whole thing should wait at least or take at least 1 second, because because this thing fails at the very beginning, it doesn't mean that it will cancel this thing, right? We should make kind of like subscribe them, and so notify them each other that when one of them fails, notifies the other. Look, I failed. There is no reason for you to continue working, right? And with just 2 futures, that could work, for example. But imagine having, I don't know, 7 That would be really challenging. Keep your fingers crossed. Let's run this test. Will it work or not? Just run. Oh gosh, I know what happened. And this time it's not me. This time it's not me. This time it is not me. Let's delete this. And now, yes. Oh, now I know what went wrong with previous demo. Kind of late. And we should go for this, structured concurrency test. And now let's run it. Yeah, so both tests are passing. The reason why it didn't work before as well, I guess, is we have to go to edit this configuration and see toss this add --add modules, right? And whatever I just click here, despite having this run configuration in this beta version of IntelliJ, it just kind of like discards this configuration. Anyway, what it means, right, that whenever we have two times quite similar in structure code with just calling two services and waiting for a response from both, right, to just combine the answer, you have two microservices. You call service A and you call service B. And even if you know instantly that service B is not going to give you any result, so there's no point in continuing calling service B, it doesn't work this way with these executors and futures, right? And it works with this cancellation with the structured task scope. As you can see, the execution was quicker than 20 milliseconds. So it was actually, the whole test took 25 milliseconds and the other took 1 second and 6 milliseconds. If the thing is visible for you right here. So this is kind of like async await that we're gonna have in Java right now, right? And it's a free cancellation. So structured concurrency. If you're happy with just having one result, like you're trying to, like, let's say calling two caches in a database, and whoever responds first, it's okay for you. So just one success is okay. You can go for shutdown on success. Just make sure you don't forget to call join and scope values. So this third thing that you could see, so it's like one main mutable thread locals which have bounded lifetime because of the scope. So as you can see, it's this scope when it's going to be like inside this run. So even if like a thread would be reused, it wouldn't see it again, right? So which means simplified reasoning and improved performance because it's immutable. So it doesn't have to be copied for every thread of this pool of million threads and so on, right? So thread local doesn't change. It doesn't even get deprecated. It's still with us, right? And you saw this stuff. Scope values, we also saw it with that they work nicely with structured concurrency. Processing data. Now, since Java 16, if I'm not mistaken, we have record as a standard data carrier, right? Instead of being just gentleman's agreement, we have a standard, right? And this means that current syntax in Java might be not so easy for data first flows, because like visitor pattern and like if else's, nested deeply. So it starts looking like this, right? And maybe there's a better way. And this way might be pattern matching for switch and record patterns, righty. And important thing, good old switch remains the same. If you have a source code from, I don't know, Java, whatever version before, and suddenly it works differently, it means you found a bug. Very nice, notify OpenJDK folks, right, that you found a bug, if you're so lucky or unlucky. Now we can have something like this, right? So basically, instead of having this if-else's, I can switch over an object. See, this is an object. So I can switch over it, and I can have this guard, right? Just make sure it's not below, because then we'll have the case of a dominant case, righty. It gets more null friendly, as you can see, because now I don't have to guard it with if null, then do something else. And yeah, default stay with us, and you can combine null and default. Previously, you could combine them like in more sophisticated ways, but as of Java 20, it's null goes alone or with just default, nothing else. So pattern matching for switch, more null friendly. Now I'm gonna do the PowerPoint karaoke. Handles now objects, not just primitives. Dominant cases aren't allowed by the compiler, meaning if I had this greater than 17 below just integer, it wouldn't work, it wouldn't compile, right? Cases can contain this when, which is called the guard. And sealed classes are really nice because they don't require this default. And pattern matching doesn't work with primitives, right? Unless you go for auto-boxing and stuff like this. And it works both with switch expression and switch instructions, meaning if you still want to rely on the side effects as of Java 7, for example, you can still use pattern matching. However, fall through is not allowed. And it makes sense, because if you match something like match this pattern, how else, I mean, what on earth would you do that with that in the branch that doesn't know it, right? The following one. Yes, and these are record patterns. So if we have records, who's doing Scala? Just 2 hands. Okay. So for Scala people, this looks familiar, right? With case classes and whatnot. We have these 2 records, and now we can switch over these records, or and if it's value, I don't have to like do a case value v and then call v.value. I can extract this right when I'm matching, so then I can just call v, and it gets nicer because I can get deeper with this, right? So I can go with r and I for imaginary part, and then I can just use them here instead of having this chain like complex.real.value. Right, I can just match it here, and at least now the name doesn't have to match the one that is coming from the definition of a record. Very nice if you need to like process a lot of data and compact your stuff. Yes, they allow deconstructing records with nesting. That's very nice. And right now we cannot, unlike in Scala, write our own unapply method. It means it has to be record or nothing. Maybe in the future we'll be able to write kind of like opposite of a constructor, right? So when a compiler sees the thing, knows how to extract things from the inside. Right now, it's records only. And it works both with ifs and switches. So if you want to like record match, use the record patterns in your ifs, it will work as well. And native stuff. And I was here watching very nice presentation of Nikolai, and maybe I'm mistaken, but he said something like nobody wants to deal with the native stuff. Well, I'm nobody. Hello. Yes, sometimes we deal with native stuff, and yeah, it can be unsafe, right? In aspect of time, range, and threads, and it can be tedious because of these stubs, header files, compile, update, make sure it's synchronized and whatnot. Boring. And it can be limited because like byte buffer, 2 gigabytes and whatnot, right? So, and slow, of course, because we want to have in general performance with these new native things not worse than JNI. So, 2 JEPs, especially foreign function and memory API is a long story lasting at least 6 Java releases, if I'm not mistaken. Yeah, and what are the building blocks of the foreign memory access? There's the segment, right? And we can say it's a native memory or array. There's address, because it models the address. You can pass the address between parts of your program or system. There's memory layout describing you, for example, it's going to be sequence of ints or longs or sequence of structs, and every struct inside is going to have 2 ints, and so the story goes. And what's also important, it provides us boundary for time and thread, right? So we can say, and this is very nice for try with resources, this part of memory I'm going to use from here till here, and I can say it's open for every thread or it's just confined to my thread, right? So it makes like sure that nobody is messing with my memory. It's my own and my precious, right? And we can use var handles with that. Yes, and this is how it can look like. See, and it's not complicated. Now we can use this instead of these stubs, .h, .o files and whatnot. So we can say that our memory layout is a sequence layout of 10 Java ints, right? And we open an arena which is confined, meaning only my thread will be able to manage this thing. And then I can say allocated off heap, because reasons. And then I'm going to say, and it's of course it's naive and demo code, right? That for every element that is there, I'm going to set it to exactly the same value as the index is, and then I'm going to read it, right? So when running this code, I just get 0, 0, 1, 1, and so on. As you can see, the 10 is only here, right? So then I don't have to I can rely on these memory boundaries, right? And if another thread wants to access this memory segment, then it will get just basically an exception that it's not yours, it's confined. Yeah, very nice. And it's needed Why it's needed? Because we want to, like, for example, prepare, like, occupy and pre-populate this this memory, and we want to call native stuff, right? To do something with this memory, and then we can read the result from this memory, for example. And yeah, because in C there is a concept of malloc, so we allocate the memory, and it doesn't move, and it's not released until you call free or the program crashes, right? And this is like, that's why it doesn't work with Java, because in Java you can have garbage collector, and this garbage collector can start defragmenting the memory and whatnot, right? That's why it has to be off heap. Yeah, so it's about replacing JNI with pure Java stuff. Support for C only is right now, but it may extend. And this is how it looks. And let's try to make this the last quick demo of today. And I really like how it goes nicely with the presentation of Anna Maria. Yes, so I have this. I happen to have this this demo. I have a program. This program is reading its user identifier, and then it says, "Oh, if you try to run me as root, please don't." This is what it does, and then it continues with the usual business logic. Yeah, as you know, right? And how do we get this UID? Now, instead of calling mx bins or whatnot, we can go like this. We can call the native linker, right? We can get this standard lookup, and this is like sort of the most dynamic part of it. The name of the function is getuid, and I know it because I've read the manual, right? And if it's not there, I'm just going to have an exception. And then I sort of saying or trying to describe how this function looks like, kind of like tell Java, hey, this is the signature of this function, right? It accepts this and will return you this. And then I'm going to create so-called downcall handle, and then I'm just invoking this handle. See, the only dynamic part, which is not guaranteed by Java compiler, is this thing. No more obscure files, compilations somewhere else. And then, yeah, this is it. And then the question is, how can I run it? So let's run it like this. I'm again creating a container, right? Copying the stuff I have, and then I'm trying to see if when I run it, it should. Because when I run it as a root by default, right, I didn't have any Docker file with add user or whatnot, then I expect it to return something, not to end gracefully, and to tell me, oh no, don't run me as root. Let's see if this code works. Maybe it should be here. I don't know. Let's keep our fingers crossed. See, oh, it's disabled. Yes, that's why it didn't work. Yes, let's see. Yes, it doesn't work. Very nice. This worked instantly. So the test basically, maybe I can put a trap here, like a little breakpoint. Let's see this thing. Yeah, to just tell you that I have called my program, right, my Java program, and the result of this call is exit code 42, and standard output is running with UID. And that's it, and it tells me then that in standard output error, don't run me as root, right? And I'm just asserting it in my test. So it's easy to create these tests. And in case you were wondering why my machine isn't spinning its fans, it's because the containers are not running on my machine. They just offload it to the cloud, right? This is what we do with TCC at Atomic Jar, and the whole idea is to make sure that you have more resources. And they can run your test, but not the containers, right? The containers could be easily offloaded to somebody else. Right, so random things to just conclude this wonderful conference. There are changes with every Java release to garbage collectors. That's why you should really upgrade your JDK every time it gets released, because you get these upgrades for free, these improvements for free, right? Who observes like issues with slow startup of their Java application? Okay, not that many Spring users. Very nice. In case you do, you might be interested in the term, just, Google for CDS archive. Every or almost every Java release has improvement in this area in this area as well, right? So CDS archives for the win for the fastest startups, unless you can, of course, growl, but Alina is describing this in another room. Unicode 14 became a thing because apparently world needs 37 new emojis. I mean, how could we live without all these emojis? impossible. Now, it turns out that for 25 years or 27 years, we were living like savages because we were writing to standard output, a standard error, and we didn't know what was the encoding of theirs. Now we know, thanks to these system properties, there are more additional time date formats. And now we can, if you know that you're going to create hash maps for 2,000 elements, you can create hash map of this size so it doesn't get resized dynamically and garbage collected and whatnot. And there are, of course, more changes coming in this Java 20. 20, yes. Deprecated stuff, locally constructors. Now you should call locally.off, right, to get locally. Very nice thing going us closer to Project Valhalla as well. And some future stuff. Yeah, so these are JEPs that are, as of today, confirmed to, or like planned to hit Java 21. As you can see, record patterns and pattern matching for Switch should become like a real thing, right? Production ready. And this might be the best thing. As of yesterday, kind of like there's a JEP proposal, meaning that this would mean that virtual threads will become a standard feature of the next Java release, Java 21, this September. So, I mean, God should have mercy upon you who didn't upgrade your programs to run with modern Java. Really, now it's like, now you're going to see the train missing. Yeah, okay. Meine herzliche Bitte, always provide feedback to the conference organizers and the speakers, right? So you should have your badge, and on this badge you should have this QR code for like voting on this talk, what was okay, what wasn't okay, what could get improved. Unless you don't have this application or you're watching us like on YouTube and you still would love to like let me know how it was. This is it. This is anonymous poll. Just scan the code and fill the anonymous survey. I don't know who you are, maybe Google us. That's it for today. Thank you very much for coming here. Thank you very much for coming to Vox Day Study. If you want to follow me on social media for more IT stuff, Java advices and pool life advices, I'm here. And these are the slides for you. I'm available to chat with you after the conference. Vielen Dank. I should have said, if you want to, I still have some Polish jellies or stickers left, so please come here and help yourself. Thank you.